So in today's video then, I'm going to go through with you trigonometry, and I'm really going to, in this video, introduce trigonometry to you. So you might have some understanding of it, you might not. But I would definitely recommend that you watch the videos on similar triangles and also on Pythagoras' theorem if you are coming to this for the first time, just so that you've got a bit of an understanding as to what's going on. So I'm going to very much go through with you trigonometry, and we're only looking, by the way, at trigonometry in right-angled triangles at the moment. And I'm just going to talk to you a little bit about what it all is, because it can be a little bit confusing. Now, you will need your calculator for this, and do make sure you've got it alongside you. And I'm going to go through quite a lot of examples, so I would recommend that you take this slowly and that you pause at different points and just reflect on what you've done, and perhaps have a go at the examples yourself as you go along. So first of all, just a quick intro into what it's all about. So you will see already on the board I've got these three words, sin, cos, tan. Now for a start, they are abbreviated to three letters. Their long words are sine, cosine and tangent, and those are the words that you will find maths teachers using all the time. The other thing I've got here is a Greek letter called theta, and quite often this is used to label an angle in maths. So don't be afraid of that, it's just a letter like A, B, C or D. It's a Greek letter, and we do tend to use it for angles in maths. So first of all, let's just talk about right angled triangles. Now you will have done, hopefully you've gone over and done Pythagoras before. These are two Pythagorean triples, but they're also similar shapes, and the reason they're similar, this is a triangle that's 3, 4, 5, and if you go back to Pythagoras' theorem, you'll know that 3 squared plus 4 squared equals 5 squared, and so we know that that works, and these are all whole numbers, which is nice. If I then double all of those sides, I get this triangle here, which is 6, 8 and 10, alright? Now what's interesting, obviously with similar triangles, we already know that as long as all the angles are equal inside the triangles, and the sides are in the same ratio, and we only have to have one of those conditions to be true for the other to be true with triangles. If I've then doubled all of these sides to give me this, then that means that all these three angles here have to be exactly the same in the two triangles. Now, we know that to go from 3 to 6 we times by 2, 4 to 8 we times by 2, and 5 to 10 we times by 2. But there's another property as well, and that is because of the fact these are all in the same ratio, if I divide certain sides within the triangles themselves, they have to be equal. So for example, let's say I did 4 divided by 5. That is the same as doing the equivalent here, which would be 8 over 10, and you can see they are both 0.8, okay? And likewise, if I do 3 divided by 5, that's going to be the same as 6 divided by 10, these two sides here, and that's equal to 0.6. I could also do 4 divided by 3, and that would be the same as 8 divided by 6, and that gives me 1.3 recurring, 4/3, 1 1/3, or 1.3 recurring. You might think, okay, that's fine, I get that, why are we talking about this? Well, these three numbers here actually are related to the angles. So the angle we're talking about in particular is this angle here, this 53.1, and if you draw this accurately and measure that to one decimal place, that angle there is 53.1. Now, sine, cos and tan, that's where they come in, because actually sine of that angle is basically equal to those two sides divided by each other. And because of the fact we've got similar shapes, it doesn't matter how big or how small I make that, the ratio of those sides is the same. So what sine is the ratio of the two sides in a right angle triangle which produce this angle here. And we can get that for any angle we like, okay? So I've given you 3 examples here. This is the sine ratio, this is the cos ratio, and this is the tan ratio. And basically all it is just you're dividing two sides in the triangle in relation to a particular angle, okay? And the angle we're talking about is never the 90-degree angle. We're always going to be dealing with the other two, so it's one of the other two. So in order for us to do this, we need to be able to label the sides in the triangle. So here is a right angle triangle. I've labelled this angle. I'm going to use this angle here. I could have used that one equally, but I'm choosing this one here to begin with. Now, from Pythagoras' theorem, we already know the longest side in a right angle triangle is called the hypotenuse. So this one here is called the hypotenuse. And I tend to abbreviate that to HYP to make it easier. Now, the other two sides are called the opposite and the adjacent. Now, opposite, we know what opposite means. If I'm stood here and someone else is stood there, we're opposite each other. Adjacent, really, it's just a posh word for next to. So that's like if I'm stood here and someone else is here, we're adjacent to each other. Now, it depends on the angle that we've chosen. So if I'm using this angle here, okay, then my opposite side is the one opposite the angle. And then the side next to it is called the adjacent. Okay? Now, coming back to these, as I said here, these were the three ratios. So the 4 and the 5 came from us doing the opposite and the hypotenuse. So the ratio for sine is just opposite divided by hypotenuse. Cosine is this one, so that was the one next to it, divided by the hypotenuse, so that's the adjacent. And tan is the opposite divided by the adjacent. Okay, and that is it. Now, as I say, I could have labelled that differently, so I could have chosen this angle here, and if I had have done, the only thing that changes, hypotenuse is always the same, but this side would have been opposite and this side would have been adjacent. So it depends in the question on what angle it is you're looking at. So those are the three formulae, okay? Now, I have got, and I always use this with my students, 5 steps to success when you're answering trigonometry questions, okay? We've got 3 examples which I'm going to do with you now, and we're going to follow these 5 steps. And at the moment, you're probably thinking, well, how on earth am I going to use this? Essentially, these 3 formulae mean that we can find a missing side or a missing angle in a right angle triangle as long as we've got 2 pieces of information, okay? And I'm going to take you through how to do that. So I'm going to do 3 examples for sine, 3 for cos, and 3 for tan, okay? So to begin with, I'm going to do the sine example. So you can see I've already got those up on the board here. Make sure you've got your calculator to hand, and I'm going to take you through these steps and we're going to answer the questions. By the time we get to tan, you'll be well practiced. So, first of all, in each of these questions, I've just labelled X, Y and Z for the thing that I want to find. The question is, find that missing letter, okay? Now the first step with all of these questions is going to be to label the triangle, so it's a good idea to practice doing this. So I'm going to get my red pen out. I'm using this angle here is 30, that's the angle I've been given, okay? So I'm going to label using that. Now the hypotenuse is always easy to identify because it's opposite the right angle, so put that one in first. And then the opposite side, there's your angle, that one is opposite, and so the other one left is the adjacent, okay? Step 2, we're going to write the formula. Now, I've got the formula here, we're using sine, so the first thing I'm going to do is I'm going to write down sine theta equals opposite over hypotenuse. And then, number 3, substitute in the values. So that's the values you've been given in the question. So, sine, now instead of theta, theta stands for the angle. Okay, remember I said to you that angle, that letter theta we use to represent the angle. So instead of theta, we're going to write 30. So sine 30 equals, and then its opposite, okay, opposite is the one we don't know, so that's x over hypotenuse, which is 12, okay? Now, this is the most tricky step, but stick with me, honestly I'll make it nice and simple for you. We now need to rearrange. We can't do anything with that until we have x equals. Now, when the unknown is in the numerator of the fraction, the easiest thing to do is we're just going to multiply by the denominator. So we end up with x equals 12 times sine 30. Now notice I've done all of that and I haven't touched my calculator, because we don't touch our calculator until we get down here. We have to put all the working down first, and you get marks for that in the exam. Now, a couple of things about a calculator. On the top of your screen, you should have a little D or DEG to stand for degrees. If you haven't, please go to your manual for your calculator to work out how to change it. D stands for degrees, and we are working in degrees for angles. It may surprise you, but there are other ways of measuring an angle, and if you have this in the wrong mode, then you will get your answers wrong. So that is important. So make sure you've got a D first, and then all you do is type that into your calculator. So I'm going to type in 12 times, and then you will find you've got a sine, cos and tan button on your calculator. So you type in sine, it comes up with a bracket, so when you type it on the calculator, remember to put the bracket in close to 30, and then you press equals, and the answer is 6. So you just write x equals 6, and it's length centimetres, and that's it, okay? Right, next one, we're going to follow the same steps again. So step 1, label, okay? There's my angle, there's your 90 degrees, this must be the hypotenuse, because it's opposite the 90 degrees. There's my angle, this side is opposite, so there's your opposite, and there's your adjacent. Okay. Number 2, write the formula. I've told you we're using sine, so we're just going to write sine again. You might think this is getting repetitive, but the more you write it, the more likely you are to remember it, and you do have to remember this in the exam. Then step 3 is to substitute in the values, so we're going to do that. So sine 24 equals opposite, which is 19, over hypotenuse, which is y. Now, this one's a bit more tricky, so we're going to do it in 2 stages. The first thing I'm going to do is I'm going to multiply both sides by y. And if I do that, I get y times sine 24 equals 19. I want y on its own, so I now need to divide by sine 24. So I get y equals 19 over sine 24. Now, again, calculator, type in exactly what you see there. You can either put a divide or the fraction bar. I would recommend the fraction bar because it's easier to see. 19 over sine 24, remember to close off your bracket, equals, now this time we're going to have to round our answer. So my calculator gives me 46.713 and a few more numbers. 3 significant figures is always a good rule to stick to. So I'm going to round off to here. So I'm going to give it as 46.7, and it was, again, centimetres. Okay? Now, the last one, we're actually finding an angle this time, but remains the same. So, again, we're going to label our sides, spot the hypotenuse, it's opposite the right angle, Z is here, the opposite side is over here, and then this is the adjacent. Okay? Write your formula, so number 2, write your formula. Sine theta is opposite over hypotenuse. Substitute in the values that you've got. So it's sine. Now this time our theta we don't have, we're going to call it z. So sine z equals, now opposite is 7, hypotenuse is 11. Now, we need to get what z is. So this is your rearrange step. Now for rearranging, when you're finding an angle, we've got sine z equals 7 divided by 11, 7/11ths. So we need to undo sine. So actually what we do is we do sine inverse, and it's written like this. So that's called sine inverse, okay? And on your calculator, normally, and again it will depend on the model you've got, but you press shift and sine, you'll notice it's just above the sign. There's this little sign with a -1, and that stands for inverse sine. So it's like the inverse of multiplication is to divide, the inverse of add is subtract, the inverse of sine is sine inverse. So that's all we're doing, okay? So you press shift sine and then type in 7/11. So it will look exactly like that. You press equals and you should get, in this case, round into 3 significant figures. The answer is 39.5. Okay? And it's obviously an angle, so we say degrees. Okay? So now I'm just going to clear this off and we'll do the same for cos and then the same for tan. So carrying on where we left off then, you'll notice I've still got the 5 steps written up here, but now I've got 6 more examples which we're going to go through now. So the principle remains the same. We're going to follow those 5 steps, but we're going to look at some cos examples and some tan examples so that you get familiar with how it all works. The formulae are written here, so I will sort of refer to those as we kind of go along as well. So question number 4 then, carrying on from where we left off, these are cos examples. First step, as with all of them, is you need to label the sides. So again, identify your hypotenuse first. I really would recommend that. So there's your 90-degree angle. The opposite side to that is your hypotenuse. So that's the first thing. Then there's the angle we're given. This is your opposite side, so that's the opposite, and the one left is the adjacent. Next step, step 2, is to write out the formula. These are all cos examples, so write out the formula. We're going to write out the cos formula. Cos theta is adjacent over hypotenuse. Okay. Step 3, we're going to fill in the information that we know. So cos theta is always, always, always the angle. So in this case it's 45. So cos 45 equals adjacent. Now that adjacent is x over hypotenuse, which is 12. Now step 4 is rearrange, and this I've done them in the same order as the sine ones. So if your unknown is on the numerator of the fraction, it's nice and easy. We just multiply. So we're going to multiply both sides by 12. Now that gives us x equals 12 times cos 45. Now, go to your calculator, remember to check you've got a D at the top, and then it's 12 times cos 45, remembering to put the bracket in on a calculator, and you will get, now the answer I've been given here, and it will depend on your calculator, mine's actually given me a third, it's given me the answer 6√2. Now you will want it as a decimal, so you can just press the S to D button, and that will change it into a decimal for you, okay? Now I'm rounding to 3 significant figures with all of these. I won't keep going through the rounding, obviously do check this as you go along. But we get 8.4, now that will be 8.49 because the next digit is a 5, which rounds the 8 up to a 9. Check your units, it's metres. If it's a side, it will be metres or centimetres or something like that. If it's an angle, it will be degrees. Next question then, same steps, okay? So step 1, label, all right? So hypotenuse, opposite, adjacent. As I say, pause the video as you go along so you can check all of this. And then we are going to write out our formula, step 2. And then we're going to fill it in. Adjacent side is 17, and this time it's the hypotenuse that we don't know, so that's why. Right, same as before, we're going to rearrange. Now, when I did the rearranging with sine, if you remember, we multiplied by this one and divided by the cos, the I think it was sine of whatever the angle was. There is a quick shortcut way, if you like, where actually these two just swap places. So you can do it quicker by just writing down y equals 17 over cos 52. Check back with the sine example to see how I got to that place, because it's exactly the same, it's just that in this case we've got cos instead of sine. Same thing, use your fraction bar because it's easier on your calculator, and it's 17 over cos 52. And the answer we get is, rounded to 3 significant figures, 27.6, and it's metres again. Okay. Last cos example then, label the sides. So there is the 90-degree angle, this is your hypotenuse therefore, this is the angle we're using, so this is the opposite, and this one's the adjacent. Okay, write out your formula. Cos theta equals adjacent over hypotenuse, and as I said, the more times you write that out the better, because you will then get to remember the formula, and that's really important. Fill in the information. Cos, now it's the angle we don't know this time, so that's z, is equal to adjacent, which is 15, over hypotenuse, which is 21. Now, if you remember from the sine examples, all we do is we do the inverse of, in this case, cos. So z equals, and we write cos with a little minus 1, and we keep the 15 over 21 there. On your calculator, you do shift and cos to give you the cos minus 1, and then we do 15 over 21. So obviously if it's sine, you do shift sine, and if it's tan, you do shift tan. Right, and to 3 significant figures, we actually get 44.4 degrees. Okay? Right, we're going to do the same again now for tan, alright? Same 5 steps. So, step 1, always we're going to label. So, hypotenuse, opposite, adjacent. Okay? Write out your formula. It's tan this time. So, it's tan is equal to adjacent over hypotenuse, and fill in the information that we've been given. So, tan theta is the angle, and that's 30. Right, it must always be followed without sine, cos, or tan must always be followed by the angle, okay? Oh, what am I doing? Sorry, totally wrong formula, I apologise. Tan theta is opposite over adjacent. Okay, so make sure you've got the right formula. So tan is opposite over adjacent. So opposite is x, adjacent is 10. All right. So exactly the same as before. We're just going to multiply by 10, and hopefully you can see. Look, it's exactly the same as this example here. The only thing that's changed is which trig ratio we're using. So x equals 10 times tan theta. Tan 30, sorry. So we do 10 times tan 30. Close your brackets. Check you've typed the right thing in. So this is step 5 on the calculator. Again, this gives me a third answer. That's not a problem. Press the S to D button and you can go. So to 3 significant figures, this is 5.77 and this is centimetres. Okay. Right, number 8. Labelling up again, there's your hypotenuse, that side is the opposite, and this is the adjacent. Okay, write your formula. Okay, so now fill in the information that we know. So theta is your angle, so that's 42 degrees. Opposite is 19. And the adjacent is y. So again, this is the same as this example, so remember we can do that little switcheroo. So basically the y goes up there, the tan 42 goes underneath. So y is equal to 19 over tan 42. and then we go to our calculator. So once we've done step 4, which is the rearrange, we can just go straight to our calculator, use your fraction bar button, make sure you've got the D on your screen, and we get this time 21.1 degrees. 21.1 centimetres. Right, last but not least, again this is going to be the same as this one here. Okay, so we're going to label our triangle. There's your hypotenuse, opposite side is here, adjacent is here. Okay, write out your formula. So tan theta equals opposite over adjacent. Tan theta is z equals opposite. Now opposite is 9, adjacent is 7. Okay, and z, if you remember the rearranging bit for this, same as with cos, same as with sine. To get the angle, we just do tan inverse. And so z is equal to, again, make sure your calculator's got D. You press shift tan to give you the tan minus 1, so your calculator display needs to have tan minus 1, and then use your fraction bar to do 9 over 7, and close your brackets, and you get to 3 significant figures. It's 52.1, and that's an angle, so we say degrees. Okay, and there we have it. That is a very brief introduction to trigonometry. I've taken you through the 3 different ratios, how to answer the different types of questions when you know which one to use. So in the next video, moving on from this, I'm now going to give you a mixture, and we're going to look at how to choose which formula to use. So the only difference in the steps will now be that instead of write the formula, we're going to need to choose and write the formula. Okay.